Hello, I'm Craig Boyce. I'm the Director of Professional Services with ARxIUM. I'm responsible with a team of our professionals for the implementation and support of the Riva IV automation system. Prior to joining the company, I was with a large health system where I was the Director of Informatics, and we implemented a number of solutions, including Riva. I've worked with the Riva product now for over 12 years. When we start thinking about automation in general, the entire purpose behind automating a process is to make it better. So we have to hope that the designers of sterile compounding automation or other types of automation system had the intent to improve upon the manual compounding process. When we look at how this area has evolved, it's really taken two different directions. The first can be called technology-assisted workflow, technology-assisted manual compounding, and really the second approach has been the automated compounding system or IV robotics. When we look at what they really both do though, it's focused on removing human error from the process. We know that humans are flawed and they can't do everything perfectly every time. So the idea behind these systems is, can we take out human error? And we really need to address a number of factors to do that. The first is accuracy. Is everything done properly to ensure that the dose is safe to administer to the patient? The second part is ensuring sterility. And this is where the two different approaches diverge. Technology-assisted manual compounding guides a pharmacist or a pharmacy technician into how to make the dose. However, we still have those risks of sterility breaches where the product could be contaminated with a viable microorganism. In the automated compounding systems, especially the fully enclosed systems like Riva, the compounding stages are actually protected by a curtain of HEPA-filtered air. Because we don't have the human interaction or the environmental background noise that's present in a manual compounding system, we have a greatly improved reliability and the sterility of the product. So we really have two different processes we're looking at, either technology-assisted manual, which it is an improvement because we introduce positive identification features, we have photographic evidence, and we have some degree in some systems of weight-based checks to make sure the dose has actually been prepared correctly. Automated systems, on the other hand, once the items are loaded into the machine takes over. So we have a high degree of reliability on the accuracy of the product as well as the sterility of the product. When we start talking about concepts like which is good enough, we have to consider what are our goals? What are we trying to improve on in the process? Do we have accuracy concerns? Do we have sterility concerns? And really stratifying those and making a decision on which one is the higher priority perhaps will guide the decision-making process towards the good enough decision. But when it really gets down to it, we have to think in terms of the patient that's going to get the dose. If we think about it, if it's our family member, is simply guiding a human who still presents sterility risks good enough, or do we really want a fully automated system? It's my belief that fully automating any process is better than half automation. Riva is uniquely suited in that because it truly is a fully automated system. Once the items are loaded into Riva, the robot takes over the entire compounding process, does all the necessary checks, and then outputs a fully labeled, ready to administer dose. So it comes down to making a decision on which technology really best suits the pharmacy and how well it's going to fit. The last consideration that you have to make is how does the system fit into the current regulatory environment? And probably the most important consideration when it comes to looking at technology is airflow around the system. Sterile airflow is the most important consideration to have when we look at introducing equipment into our sterile compounding process. By using fully enclosed systems, we need to ensure that fast unidirectional air protects our critical sites at all times. Doing smoke studies is the best way to do that. Riva's had numerous smoke studies done that demonstrate the high quality of the airflow. If you're implementing a technology-assisted manual compounding system, the same consideration should be taken. You need to place the equipment into the laminar air workflow bench and then conduct the same type of smoke studies. To really summarize it though, when we talk about what's good enough, we need to consider the sterility risks, how well the system mitigates potential for error, and finally, how well that system fits within our current workflow and then within our current budget to purchase that type of a system.
For more information, visit ARxIUM.com.